Dundigal. My name is Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about memory, subsystem organization and interfacing. So, what is memory subsystem organization? Say, memory is the group of circuits used to store data. Memory components have some number of memory locations, each one of which stores a binary value of some fixed length. The number of locations and the size of each location vary from memory chip to memory chip, but they are fixed within individual chip. Memory is usually organized in the form of arrays in which each cell is capable of storing word-bit information. Each row of cell constitutes a memory word, and all cells of a row are connected to a common column called word line, which is driven by the address decoder of the chip. So, what is memory chip? Memory is a very important role in the computer. Suppose I am taking CPU. In the CPU, we have ALU, control unit, and memory unit. In the previously we discussed arithmetic logic unit, and now I have to discuss memory unit. So, memory unit is the important role in the CPU. So, it is connected to the input and is connected to the output. So, memory is the storage of data. So, memory is nothing but a storing the data. So, this data in the form of registers. It will be stored in the registers. So, memory unit is a hardware and software will be there. So, this hardware is nothing but a chip or ICs. So, this hardware is manufactured with chips or IC. So, software already there. So, software is in the form of registers we have to store. So, memory unit stores the data in the form of registers or bits or bytes. So, this memory unit in the form of manufactured with ICs and some chips. So, this ICs memory is the group of circuits used to store the data. The memory components have some number of memory locations, each one of which stores a binary value of some fixed length. The number of locations and the size of each location vary from memory chip to memory chip, but they are fixed within individual chip. So, memory is usually organized in the form of arrays, which of each cell capable of storing one bit of information. Each row of cell constitute a memory word, and cells of row and connected to a common column called word line, which is driven by the address of decoder. So, every memory we need some address. In that address only we have to store the data. In address we can store data. So, that is the reason it is a memory component of memory location. Each word it stores the binary value. So, in the storing of data in the form of binary, data in the form of binary, that is 1 or 0. So, there are two types of memory chips are there: read-only memory and random access memory. So, these are the major things are there: read-only memory and random access memory. So, read-only memory means it is a permanent memory. So, random access memory means it is a temporary memory. So, this temporary memory is there. So, there are so many types of ROMs are there. So, first one is a masked ROM, or simply it is a ROM, or programmed read-only memory, electrically programmed read-only memory, electrically erasable programmable read-only memory, and flash memory. So, these are the types of ROMs are there. Read-only memory is the subtypes are there. What are these? Masked ROM or it is simply ROM. PROM, programmable read-only memory. EPROM, electrically programmed read-only memory. EEPROM, electrically erasable programmed read-only memory, and flash memory. So these are the subtypes of ROM are there. So each one we'll discuss later. So memory are majorly two types. That is a primary memory and secondary memory. In the primary memory, we have to take RAM and ROM. In the secondary memory means hard disk, magnetic tape, CD, DVD, zip, disk like this, and the cache memory and the registers. So cache memory is the in between the. So we are using cache memory in between the memory and CPU. Suppose CPU is very slow. Suppose I have to I have to access fast between this one. So between the memory, I will be use cache. So between the CPU and memory, I will use cache for the fast accessing or reducing the time. And the registers means stores the data. So in the previously we discussed ROM and RAM is there. So these are the RAM and ROM are the primary memories are there. So primary memories are means RAM and ROM, and the secondary memory means externally connected means peripherals. Peripheral or externally connected to the CPU. So these secondary memories are hard disk. So hard disk is externally connected. Suppose in my memory in my computer some reduced memory means memory is not. I'm not happy with the existing memory. I want to use much memory for that one. So hard disk is connected to this one, and magnetic tape, magnetic disk, CD, DVDs like this. So some nowadays generation we are using some pen drives like this. Okay, so these are the ports are externally connected to the CPU. That is called the secondary memory. Okay, these are the secondary memory. So in the RAM, how many are there? Static RAM and dynamic RAM. In the ROM, PROM, EPROM, EEPROM, programmable ROM, erasable programmable ROM, electrically erasable programming read-only memory. So totally 5 types are there. These 3 are under ROM, and static and dynamic RAMs are there. Here 2 types are there. So cache memory is the fastest programming for between the CPU and memory. So cache memory is the fastest accessing. What is the use means? Less time and fast accessing. Less time and fast accessing. For this one, I am using cache memory. Okay, between the memory and the CPU, we have to use the cache memory. And registers are nothing but it will store the data. So if I am taking the cache memory means, suppose I am taking so between the memory and the CPU, I have to use cache memory. Okay, it is a temporary memory, and it is connecting between the CPU and memory. Okay, so when the CPU is some more number of programmings are there. Suppose I have to increase the lifetime of the CPU. Suppose some programmings are there. Without the CPU, I have to use some programming, some non-programming works. So there are some task I have to use task that is a non-programming. I don't want any ALU. So I don't want any logic gates. So for that non-programming, I have to use cache memory directly to the memory without the help of CPU. So what is the advantage when we are connecting the cache memory to the CPU means fast accessing and less accessing time, and fast accessing, and we are increasing the lifetime of the CPU. And registers are nothing but these are the storing the data in the form of binary. So binary data will be stored in the registers to transfer the memory. Okay, these registers are using for the memory. Okay, so in the memory, registers are there. So set of registers are there. These type of registers are, suppose I am taking 10, it is a 2-bit. Suppose I am taking 8-bit. 10, 11, 10, 1, 2, 3, 4, 5, 6, 7, 8. Suppose it is a 8-bit memory. Okay, this memory 8-bit memory are using for the registers. 8-bit, 2-bit, 4-bit, 8-bit, 16-bit, 32-bit registers are there. So these registers are transferring the data in the form of binary to the memory. So what is masked ROM? A masked ROM or simply ROMs are programmed with the data as chip, as fabricated. The mask is used to create the chip, and the chip is designed with the required data hardware in it. So that is a PROM. And some ROM designings allow the data to be loaded by the user, thus providing programmable ROM. That is a PROM. Once a program has been written on a PROM, therefore, unlike main memory, PROMs retain their content when the computer is turned off. PROM is nothing but a memory chip on which data can be written only once. So there are so many types of ROMs are there. First one I am taking about the masked ROM. So this masked ROM are simply ROM programming with the data chip as fabricated. Okay, these are using for the programming. It is for programmable data as fabricated. The mask is used to create the chip, and the chip is designed with the required data hardware in it. And another one is a PROM. Some ROM designs allow the data to be loaded by the user, thus providing programmable ROM. Or once a program has been written on a PROM, therefore, unlike main memory, PROMs retain their content when the computer is turned off. Okay, PROM is a temporary memory. When the computer is turned off, the data will be lost. So it is a programmable read-only memory, is a memory chip on which data can be written only once. Okay, it is non-erasable. It is not a permanent memory. Once it is stored in the chip, it will be not removed. Okay, permanently it will be stored. That is a PROM. So masked ROM is a non-erasable memory. So next one is a EPROM. EPROM is another ROM chip, allows the stored data to be erased and new data to be loaded. Such an erasable programmable ROM is usually called an EPROM. So EPROM is done by charging of capacitors. The charged and uncharged capacitors causes each watt of memory to store the correct value. The chip is erased by being placed under UV light, which causes the capacitor to leak their charge. Okay, so when I'm taking the EPROM, it is a erasable memory. It is a erasable memory. So then another ROM chip allows the stores the data to be erased and new data to be loaded. Such as erasable reprogrammed ROM is usually called an. Okay, it is used to reprogrammable memory. Suppose I was one program is saved in the memory. I have to remove that program, and in that program I have to replace with another program. That is a reprogrammable. That is called erasable memory. So it is possible with EPROM. So when what are the advantages means, it is a erasable programming there. So what is advantages means, I have to use multiple types of the memory. So it is the charging of capacitors. The charged and uncharged capacitors cause each watt of memory to store the correct value. It is in this we are using some capacitors, that is a charged capacitors. By this chip, it is erased being placed under UV light, which causes the capacitors to leak their charge. So another one is a EEPROM. A significant disadvantage of the EEPROM is the chip is physically removed. So in this EEPROM, what it means the disadvantages means physically removed. Physically removed. That is the disadvantage of this one. So in this significant disadvantage is the chip is physically removed from the circuit, reprogramming and the entire content are erasable by the UV light. So in the EEPROM, what are the disadvantages are there in the EEPROM? We are overcoming in the EEPROM. So it is the EEPROM and EEPROM that can be both programmed and erased electrically. But such is EEPROM do not have remove for erasure. So we no need to remove. So no need to remove. But here physically we are removing. But here no need to remove this one. That is the advantage of EEPROM compared to EEPROM. The only disadvantage of EEPROM is that different voltages are needed for erasing, writing and reading the stored data. So what is a disadvantage? It means different voltages I need for how many are there? Erasing is the first one task, writing is another task, reading is the another, and storing. So how many tasks are there? So erasing, writing, reading and storing. There are 4 different concepts are there. For these 4 concepts I need different voltages for the removing of memory. That is the disadvantages of EEPROM. So flash memory. A special type of EEPROM is called a flash memory. Is electrically erased data in blocks rather than individual locations. It is well suited for the applications that writes blocks of data and can be used as a solid state hard disk. It is also used for the data storage in digital computers. So another type of memory is the flash memory. It is a special type of EEPROM. What is the advantage of EEPROM? Means removed from chip is easily. It is called EEPROM. So from the special type of EEPROM called flash memory. Okay. Special type of EEPROM is called flash memory. What is the advantages? Means it is a electrically erased data in blocks rather than individual locations. It is well suited for the applications that writes blocks of data and can be used as solid state hard disk. It is also used for data storage in digital computers. Okay. For the data storage, solid state hard disk data storage in solid state hard disk. It is called SSD, solid state hard disk. It is called flash memory. Okay, flash memory is now a technology. SSD computer is using with the help of flash memory. So in this flash memory, it is an advanced version of EEPROM. It is electrically erasable, and applications of this one means write blocks of data and can be used in solid state hard disk. It is also used for data storage in digital computers. That is the advantage of flash memory. And RAM chips. RAM stands for random access memory. This often referred to as read-write memory. Unlike the ROM, is initially contains no data. The data pins are bidirectional, unlike in the RAM. Okay, RAM chip is nothing but a temporary memory. It is a temporary. So RAM stands for random access memory. This often referred to as read-write memory, and unlike the ROM, is initially contains the no data. The data pins bidirectional, unlike the ROM will there. When the no data means there is no, automatically the power is off, the data will be lost. It is a bidirectional of the ROM. And the RAM chips are different based on the data they maintain. Dynamic RAM, DRAM, and static RAM. There are 2 types of RAMs are there, static and dynamic. So first one we discuss dynamic RAM. So DRAM is nothing but a dynamic RAM. DRAM chips are likely leaky capacitors. Initially data is stored in the DRAM chip, charging its memory cells to their maximum values. The charging slowly leaks out and would eventually go too low to represent valid data. Before this, a refresher circuit reads the content of the DRAM and rewrites data into its original locations. DRAM is used to construct the RAM in personal computers. Okay, so when I'm using the DRAM, chips are likely leaky capacitors. Initially data is stored. Okay, this charging of memory cells on their maximum values. The charging of slowly leaks out of the memory and would eventually go low to representing valid data. Before this, a refresher circuit reads and contents of the DRAM and rewrites data to its original locations. DRAM is used to construct RAM in personal computers. Okay. So the charging of slowly leaks out of would eventually go to low to represent valid data. Before this is a refreshing circuit reads to data event of the DRAM and reads data to its original locations. And the DRAM used to construct the RAM in personal computers. Okay, and another one is a static RAM. Static RAMs are more likely the register once the data is written to SRAM and its content stay valid. It does not have to be refreshed. Static RAM is faster than the DRAM, but it is also much more expensive. Cache memory in the personal computer is a constructing of SRAM. Okay, we are using here static RAM. So in this static RAM, it is a faster. Static RAM is a faster than DRAM, but it is a more expensive. But which one is better means SRAM is a better compared to the DRAM, and the cache memory in the personal computer is constructed from SRAM. But the SRAMs are nothing but a static RAMs are more likely the register once the data is written to the SRAM to content stay valid. It does not have to be refreshed. So it is a block diagram of ROM. It is a construction of ROM. So here I am taking A1, A2, A3 are the address lines which are using to the connecting to the ROM. It is a 8 into 2. So 8 into 2 means 8 input lines and 2 output lines. So 8 into 2 means I am taking 2 cube into 2. So 2 cube equal to 8. 3 input lines and 2 output lines. Okay. So 8 lines. 3 lines means 2 cube equal to 8 into 2 and 2 output lines are there. That is the data lines. Okay. So input is the address line. Address line to the data. Input is address and output is a data. Okay. So 3 address lines are there and 2 data lines are there. That is the D0 and D1. It is connected to the A0 and this gate. So this is connecting to the CE and it is connected to the OE. So another one is a ROM. It is also 8 into 2. So 3 address lines and 2 data lines are connected to this one. So how many data lines are there means D0 and D1. How many address lines means A0, A1 and A2 or A1, A2, A3 are the address lines for this one. So there is from the above technique for joining memory chips to form a memory subsystem. 2 or more chips can be combined to generate a memory with more bits per location. This is done by linking the corresponding address and control signals of the chips and linking their data pins to various bits of the data bus. For example, I am taking 8 into 2 chips can be combined into to generate 8 into 4 memory as displayed in the figure. Both chips get equal 3 address inputs bus and some enable of the enabled signals. So I am taking as a 2 cube into 2, that is a 8 into 2 ROM is there. But here 2 or more chips can be combined. 2 or more chips can be combined physically. And this is done by corresponding address and control signals of the address lines are there and the data lines are there. This address and data lines are belongs to the control signals of the chip and linking the data pins to the various bits of the data. It is a 8 into 2 chips can be combined to generate 8 into 4 memory as displayed in the figure. Both chips get equal 3 address inputs from the bus and the same chips enabled and output enabled signals will be there. So the data chips of the first chips are linked to bits 3 and 2 of the data bus and those of the other chips are linked to bits 1 and 0. When the CPU reads the data, it locates the address on the address bus. Both chips of the address A0, A1, A2 implement their their C and OE signals are activated. The chips of the output onto the 4 bits. Okay, so output is D0 and D1. So what is the control signals are there? CS is a control signals are there. So the address and enabled signals equal to the both chips. Either chips or neither chips are active in the given time. The device never has only of 2 active. For this reason, they facilitate only signals with 8 into 4 chips at least until the CPU is connected. And instead of generating wider watts, chips can be combined to make more. 8 into 2 chip size can be using for the ROM and 16 into 2 memory is also using for this one. So the upper chip of configuration is from 0 to 7, that is from 0000 to 0311, and the lower chip of 8 to 15, that is 1000 to 1111. The upper chip always A3 equal to 0 and the lower chip is A3 equal to 1. This difference can choose one of the chip when A3 equal to 0 and the upper chip is enabled and the lower chip is disabled. The output enabled can be linked because of the chip is that enabled with the output data. Both chips are corresponding to the similar data of D0 to D1. So when I am taking the input to the output, so input chip and it is the output chip, and between this one is a control chip. So control means between the input and output we are using for the control chip CS. So it is a diagram or construction of 8x2 ROM. 2 ROMs are connected with this one, and what are the data lines means D0 and D1 are the two data lines, and here 8x2 ROMs are connected. So input chips and output chips are there, and C is a control chip, enabled chip, or output chip OE is the output enabled, and C is a control enabled. And this configuration of high order interleaving, all memory locations inside the chip are continuous within the system. Consider the configuration of display in the which use low order internal leaving. The upper chip is enabled leaving Aeronautical 0 by address 000. In this case 02467. The lower chip is enabled A0 equal to 1. The corresponding address are the 1357911 1315. So when I am taking the A0 and A1 even numbers. So A0 is enabled, even numbers for lines are enabled. When I am going for the A0 equal to 1, then the lower chips are enabled, that is the odd numbers or lines are enabled. And it is a diagram of ROM, 2 ROMs are connected, A0, A1, A2 with the data lines of D0 and D1, and chip enabled and output chip enabled are there. And these are the references. So we discussed today. What is the memory? It is an internal group of circuits are used in store. So it is manufactured with ICs and chip and a group of circuits. And there are two types of the ROM and RAM. And ROM are the masked ROM, PROM, EPROM, EEPROM, and flash memory are 5 types of ROMs are there. And it is a memory organization. Primary memory, secondary memory, cache memory, and the registers are there. In the primary memory, RAM and ROM. In the RAM, two types, static and dynamic. In the ROM, majorly PROM, EPROM, and EEPROM. And secondary memories are hard disk, magnetic tape, CD, DVD, zip, disk, etc. So, what is masked ROM and what is PROM? Masked ROM, PROM are the non-erasable ROM, and EPROM is the physically removed. It is a disadvantage, and it is a non-erasable memory is there. Okay, and EEPROM means physically it is not possible to remove, but need not to remove, but permanently it is memory is there. So if you want to remove, we can remove. Okay, it is a erasable memory. And the flash memory is using for SSD, solid state devices of computers. And RAM is often referred to as the read-write memory. Unlike ROM is initially contain no data, the data pins are bidirectional using to the ROM. And dynamic RAM and static RAMs are the two types of RAMs are there. So dynamic RAM chip and slowly charging and it leaks. And static RAM is a connections of ROM 8x2 ROM with internally connected to the memory. Okay, it is about the static RAM. Okay, it is about the memory system, subsystem organization and interfacing. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.